Hi. In my previous video, I talked about the pleasure and the gratefulness that I experienced when working with NVIDIA's DGX2. So thanks again, NVIDIA, for giving me access to this really powerhouse that really lifted my AI music experiments to the next level. Today, I would like to talk a little bit more about details. So very, very interesting stuff that happens under the hood. Before I start talking about these things, please be so kind, subscribe to the channel. Also, if you liked the video, like it. If you have any questions or comments, use the comment section. Looking forward to reading from you. Well, here, DGX2, oldie but goldie, established in 2018. Still a very, very good and strong piece of hardware. Strong in the sense that it has a lot of compute. Also, it's very heavy, 163 kilograms. So this is the beauty. The one that I use lives somewhere else, so it's not in my apartment, which is good and bad because I was really, really heavy and power hungry. And people tend to like it, so it's just a great tool to work with. So please, you all feel invited to have a look at DGX2 and every other members of the DGX family by NVIDIA. Here, this beautiful, well, if I am a moth, then this is the flame. This is the loss curve, or the loss curves for one new network that I have trained. It's a new network that I mentioned recently, trained on 150,000 songs. And I trained this, I think, for 7 days. And this picture, these loss curves, show you how well the new network works from an objective point of view. So objective point of view, subjective point of view, always something that you have to keep in mind. Still, we don't have any subjective automatic measurement for the quality of music generated by AI. So you always have to listen to it. So what you see here, validation set loss curve and training set loss curve. Well, there's a small degree of overfitting in it, as expected. Underfitting also, it could train a little longer. Still, it's not the case that a loss curve for validation set would go up. So this would be a neural network that could be trained for a little longer. I'm thinking about that. But what you see here, different colors means different training runs. So I trained a couple of times, and well, every time I started a training, I did not start from scratch. I started from the previous checkpoint. And what I saw here with this first dark purple neural network is not trained so long. I mean, it was not really an entire day, it was a couple of hours. I downloaded the latest checkpoint and I saw that, well, this neural network already goes in the right direction. When it comes to music notation, the whole syntax, just fine. It generated music, but I had a feeling that it also struggled a little with harmony. So sometimes it got a couple of notes wrong, and then I had to recreate the entire generation. And then I continued a little longer, and I saw the longer I train, the better the generated musical material became. And then I decided, well, let me just see if I can run into overfitting. So I trained this new network for a couple of days. So it's 1 million global steps, and I think a step is 112 samples per batch. So there was quite some computing going on. Here, on the other hand side, is the notebook that I usually run at home on my computer. And this notebook is just me. I'm getting access to all those new networks that I have trained. So this is my collection, which blocks quite a lot of space on my hard drive of different new networks that I've trained. And here, Lakh Clean, that's the data set that I've trained on, 150,000 MIDI files that I can work with. The original data set has 175,000, so I had to filter a couple of them out, which caused a little trouble in my pre-processing pipeline. But nevertheless, 150,000 MIDI files, that's quite a lot to listen to. And I have a couple of other neural networks already up my sleeve, which I can talk about later. Coming back, assessing the quality of musical material generated by AI. So here I just run it. GPT-2 is the neural network that I've trained, and it generates music. And this is a good example. This good example is conditioned on string ensemble. So the neural network would only generate string ensembles. So let's see or hear how it sounds. Very, very nice, very harmonic. I like this a lot. And this, oh, well, this ends the entire story. So I started training a neural network on a lot of data on the DGX2. And then I downloaded all the checkpoints, and I could play a little with all the different checkpoints to my local machine. And in my local machine, I do the experiments. I generate, and then there you go. Well, next steps for me would be, I have more neural networks to train, which will keep me quite busy. And I also have to integrate this neural network into the tool or a tool for like to make the whole composing experiment or the experience way more exciting and more straightforward for people. Composing in Jupyter notebooks is okay, but you would like to have a high degree of interactivity where you can do magic with individual bars, maybe recreate an entire track, add a new instrument, and so on and so forth. So please be so kind. If you're interested in that, I've already uploaded a few videos where you see me composing with AI, where I compose heavy metal music. Thank you very much.